Hello guys, so today we are here to solve our daily lead code challenge for the day. This problem is minimum number of changes to make binary string beautiful. And if you look at this problem, minimum, maximum, whenever it occurs, the first thing that comes to mind is that this is an optimization problem. Okay, so see, if we think that this is an optimization problem and we start going in the line of greedy or dynamic, then we might be mistaken. And this problem is a very good example of that thing, that if you start looking in that direction, that might not be the right way to go about this problem. Then let's further go and dig deep into the problem statement. Okay, so if you look into the problem statement, you'll see that you are given a zero indexed binary string as having an even length. Okay, so this string is the input string is having an even length. It's not odd length, it's not zero length. It could be zero length, it's not odd length at all. It's only and only even length. 2, 4, 6, all these, whatever is even, that is there. Then on the second line, it says that a string is considered beautiful. A string is beautiful. It is beautiful if it is possible to partition it into one or more substrings. So if it is possible to partition it into one or more substrings, partition means disjoint, disjoint subsets. So each substring has an even length. Each substring contains only ones or only zeros. Each substring contains only ones or only zeros. Okay, so this is this has some serious implications. These two conditions have some serious implications which we must understand. It is saying that the input string itself is of even length, and then we are dividing the substring also in even length, and the substring contains only ones or only zeros. Okay, and then it is asking return the minimum number of changes required to make the string as beautiful. So see, there are few things in this. A string is considered beautiful if it is possible to partition. And as soon as we read the word partition, I don't know why, but to me actually, what flashes is divide and conquer. Okay, but we will see that divide and conquer is also a wrong, a very wrong lead to follow in this problem. Okay, now we will go through this problem, and we'll try to experiment with it and try to understand what is that is being required to be done over here. Now you see, this is an string of length 4. All strings will be of even length, and this string is of length 4. How are we going to solve this? See, in this, how can we beautify this string? To beautify this string, we need to find substrings of even length. So substrings of even length are this or this. Okay, so this or this. Okay, each substring contains only ones or only zeros. Each substring contains only ones or only zeros. You can change any character in S to 0 or 1. Okay, return the minimum number of changes required to make the string S beautiful. Okay, now how are we going to solve this? So this given string 1001 can be divided into two substrings of even length, length 2 2, 1 0 and 0 1. Now to beautify this 1 0, we need to either convert 1 to 0 or convert 0 to 1. And same for the other substring 0 1 also. Either we convert 0 to 1 or 1 to 0. Okay, and in both the cases the minimum number of changes will be 2, because either we change this one and make it 0, or we change this 0 to make it 1 for this 1 0 substring to be considered as beautiful. And then same is the case with 0 1 also. And for overall we need to do two two minimum changes. So with this, how are we going to solve this problem? So overall, when it is two minimum changes to be done, how are we going to solve this problem? So what do we need to do here? I think we consider some other example, then also it will be clear to us. So see, for four, the length four string, the minimum changes is 2. Now for this only length 2 strings, the minimum changes is 1, because either we can change 0 to 1 or 1 to 0. In both the cases, the minimum changes will be 1. Okay. And what if we have something which is of length 6? So 1 0 0 1, and then 1 0, again 1 0. So here we have this string, something like this. So let me create a string here. Okay, and then it is 1 0. Okay, so what is the number of changes, what is the number of minimum changes that we need to do here? See, either we make this 1 0, okay, we make this 1 0 both as 1 1 1 1, or we can make this as 0 0. Okay, in both the cases the total number of changes will be 1. Okay, and then if we consider this 0 1, okay, either we make this 0 1 as 0 0, okay, or we make this 0 1 as 1 1. Okay, in both the cases the minimum number of changes will be 1. And then for this last pair, what is the possibility? For this last pair, the possibility is 1 0, then either we can make it 1 1, or again for we can make this 1 0 as 0 0. And in this situation also the minimum number of changes is 1. So 1 plus 1 plus 1 is 3. So for a substring of length, or a string of length 6, the number of changes is 3. So is it that this thing is giving an idea to us? And what is that idea? That we can return the length of the substring by half. If we do the half of the length of the substring, then we will be closer to the answer. Okay, so if we do this, and say return s dot length by 2, okay, I'll do like this. Why are we doing it by 2? Okay, so see, two cases are being fulfilled here. This case is being satisfied, and this case is being satisfied, but few cases are not satisfied. This is, see, this is all zeros. Okay, and we are just blindly considering the length of the string. We should check the individual character bits also. So to do that, what we can do, if check all bits same, okay, and pass this string, and let's create this n is equal to s dot length over here, and pass this n as well. Okay, so, and if it is same, then we'll return 0. Okay, because in this case we don't need to do any changes. If it is all ones, then also we don't need to do any changes. So if it's all same, we can just return 0. So how to check whether it is all same or not? What we can do here, that we can just return boolean over here, check all bits same. Okay, and then we'll be passing this string s, and then int length. Okay, and what we will do, that char c is equal to s dot charat 0, and for int I is equal to 1, I less than length plus I, and then we will check if s dot charat I minus 1 is equal to s dot charat I is equal to return, if it is not equal to, then we'll return false. Okay, otherwise what we'll do, we'll return true. True. Okay, if we do this, then our job is done. So there is still one more case which is not correct, and in this case, see, these two are 1 1, these two are 0 0, so obviously it is not all same. Okay, but the problem here is causing this bit, and in this bit this double bits, it's 0 1, and the expected value is 1. So this is causing problem, and in order to fix this, what we need to do, we need to add one more check over here. Okay, so what is that check? We can check pairwise. Check pairwise. Okay, check pairwise equality. Okay, and in this we'll pass this string and the length n. Okay, and we'll get some value. Okay, how many pairs are not uh, equal, and our job will be just to return this count. We don't need to do any other thing. So this thing is not required at all, because this thing was blindly taking the length of the whole string and then doing it by 2. This was correct when there are cases, when there are test cases like 1001. So they are mismatch twin characters, but there are two such mismatched twin characters. There is one such mismatched twin characters. So this was true in that case. So we can remove this and just rely on this count, or better still we remove this count variable and directly return the value of this method call. Okay, so that will be the best. Okay, so we can do one thing here. Private int check pairwise equality. Okay, okay, and then we'll pass this string s and then this length n, and then here what we will do, that we will do int count is equal to 0 for int I is equal to 0, I less than. So see, we have to do pairwise equality, so we don't have to I less than, we have to do I plus 1 is less than n. Okay, and then we have to move pairwise. I mean to say, we have to check first two, then we have to check third, fourth, then we have to check fifth, sixth, then we have to check seventh, eighth, like that. So I plus is equal to 2, like this. Okay, and in this case what will be happening here, that we will be putting our checks like this. If same thing, s dot charat I is not equal to s dot charat I plus 1, then we have to do not equal to I plus 1, then we have to increment the count. Okay, and finally we have to return this count. Then we have to return this count. Okay, and I hope this will take care of all these things. See, this is perfect. So see, here we are checking whether all bits are same or not, and here we are again doing the same thing. So why not just take this. Okay, take this logic. Okay, remove all this. Okay, and then put it over here. Okay, and remove all these things. These things are not at all needed. We can just leave it like this and run this. Perfect. Let's submit this. Solved. Happy coding. Best wishes. Thanks a lot.